Hi, everyone, and welcome to today's SQL Office Hour session. Today, I'm really pleased to have some of the XML team with me here today to talk about what's new with XML in Oracle Database 23c. So we're talking about sharding and the XML search indexes. We've got Alonso, Rodrigo, and Madhu who are going to be explaining these. These people are very close to these features. They know way more about this than I do. So I think it's really good to have them here and explain how XML works. So I think that's enough for me, and I will hand over to Alonso to kind of take you through it and get started. So Alonso, please take it away.
Yeah, thanks, Chris. So hi, everybody. I'm Alonso. I'm a developer for XML database. So I'm very happy to be here and talk to you about some new features that we are developing, just to catch up on these new technologies and new infrastructures that are nowadays running. And yeah, the way we are kind of enhancing our XML product. So the agenda for the first part of this presentation is I'm going to talk to you about sharding, which is a database architecture that is a distributed architecture. So I'm going to talk to you about a little bit what is it, and then some use cases and how we are developing XML on this new architecture. So sharding is a horizontal partitioning architecture. So it looks like a large database, or it is a large database, but it is split into many independent databases. So these individual databases are called shards. This is a technique, or this is architecture, just to have better performance and better distribution of the information. And as it is horizontal, we have in each shard, we have a completely independent database. So it's a share nothing. I mean, each shard know nothing about the other shards, but they are all coordinated by the catalog, which is the one that shows like everything just only like one database. So it is transparent to the user. We may see it like only one database, but in fact, there are many databases coordinated and working just as one. So it's kind of the idea of the sharding architecture. This is some principles of the sharding architecture. Is a hyperscaling of the computing. As I mentioned, is share nothing, and there's a coordinator and a shards. So here in this slide, we can see how does a shard table works and how the duplicated table works. These two flavors are specific for a sharding architecture, and pretty much the sharded tables are gonna send or balance the information among the shards. So depending on the shard key that you specify, the information is going to go to a specific shard, and it's going to be split into them, and data is going to be stored there. So whenever the catalog or the coordinator query information from the sharded table, the shards are gonna run this query, and they're gonna return the rows to the coordinator, and then the coordinator is just going to gather those rows and show them. So that's why it just looks like a one database, because you're basically just running one query, but underneath we are running the remote query in each shard, and then fetching those rows that are stored in each shard and showing all of them just as once. And this is also improving performance, because the workload is going to be distributed across the shards we have, and coordinator is just going to gather the results. So this is also for improved performance. And the duplicated table on the other side is basically, we're gonna replicate all the information across all the shards. So as you may see here in this slide, we have the duplicated table. We have all the rows replicated in all shards. So this is for a different use case. Say we want the same information in all the shards. And yeah, basically this is a way to do it. Yeah, some of use cases are for hyperscaling. As I mentioned, it increased the database size and the throughput, and this gives us elasticity. It's also fault isolation. Say we have duplicated tables, for instance, and some shard in some region just falls down. We can get to another region and have the exact same information. So there's no impact on others, and we can still, from the coordinator, see the data. So that's also another use case. And lately we have the data sovereignty. This is the user-defined data placement for complying with regulatory requirements. Basically, the data stays where it belongs. And yeah, that's a little bit about the use cases and the background of sharding. So going on with DML, this is the way, sorry, the DDL, this is the way to create a sharded table. This is issued from the catalog or the coordinator. And basically what we are saying is that we are going to create a sharded table called purchase order. So, and then we need to have a specific primary key. In this case, we are combining two columns to create our primary key, which is the purchaser ID and the country code. So this is this constraint is going to be used to partition our sharded table. So basically, sorry, the column ISO country ID is going to be used to partition our sharded table. So whenever we insert a row where the ISO country code says region 1, it's going to go to certain table space. And underneath, the sharding configuration could be that this table space belongs to shard 1 or shard 2 or shard 3 or whatever you want to set up. And then if you find the region 2, you're going to send it to another table space, which could belong to another shard, and so on. So in this very example, for the demo I will present later, basically table space 1 belongs to shard 2, shard 1, table space 6 to shard 2, and table space 11 to shard 3. So that's why the region 1 is going to go to shard 1, the region 2 is going to go to shard 2, and region 3 to shard 3. What else? Yeah, the XML type column is called purchase order detail, and it's going to be stored as a secure file, transportable binary XML. This is all possible given this new storage called transportable binary XML, which is a standalone storage type of XML. And as it is a standalone, it could be sent across the wire and decoded in any database that is sent to. So basically, this is a new storage type, and this is the thing that allows us to do this new architecture and use this new support. So this is for a sharded table, and then we have a duplicated table. The DDL for the duplicated table is basically create duplicated table, purchase order dup, with also duplicated. And here we don't need anything because as I explained before, this is going to be replicated across all the shards, and there's no need like to have a way to partition or split because it's going to be the same in every shard. Again, the XML type column will be a secure file transportable binary XML, because again, it needs to be replicated. It needs to be transported from the catalog, which is where we are going to issue this, across all the shards. And also it's going to be, it needs to be able to be replicated. Okay, so yeah, sharded and duplicated tables can only be created in the catalog of a sharded DB. As I mentioned, this is only a DDL that could be only issued in the catalog. There's no way a normal database could create a sharded or duplicated table. So the sharded tables will split the data across the shards depending on the specified partitions. In this example, I show you the region 1, region 2, region 3, and ISO country code as a shard key to partition the data and split them across the shards. Duplicated tables will replicate the data across all shards, as I just explained. And the ML and sharded and duplicated tables are also available using direct routing, which is connecting directly to a shard. This last bullet is that there's another use case where we just could use one region or one shard in a region and connect the users directly to that shard. And there's no need for them to see the coordinator to see all the data across the sharding DB. We just need to see whatever is in that region. And basically we can connect to that shard. And as it is an independent database, it is going to be normal. It is going to be a normal database, and we can issue whatever we have. There's no, whatever we want. There's no need to create or issue anything to the sharded or duplicated tables. We can see them as a normal table, and we can use the DML as a normal table. And as it is share nothing, the independent database knows nothing about the whole architecture around. So this is a very cool feature. And then I'm going to talk to you about push down XML operators. Basically, this is what happens when we, where are we? Here. Okay, this is, where is it with my mouse now? Stay there. Okay, now, well, here. Yeah, okay. So yeah, basically, this is a very tiny, what now? Changing. Second. Why? Okay. Let me just go through the actual presentation because this is important. Just very second. Oh, this is because we have a lot of here. Okay, here. Sorry about that. Just gonna go from here. So yeah, basically this is a very simple diagram to show what happens when an application uses sharded DB. So the application just sends a query, an incoming query to the coordinator. Well, this is a use case where we use the coordinator. And then the coordinator sends to the shards some shard queries. So this shard query is also called a remove query. So basically what we are doing is getting the rows out of each shard and then return them to the coordinator, which is the R1, 2, and 3, so are the results. And the coordinator is gonna gather all of them and make a final query result, and then give it to the application. So this push down thing is the shard query or the remote query part, because when we push down most of the query, so most of the work is going to be balanced and distributed across the shards. Say if we push down a very complex query, each shard is going to do that job of the complex query parallelly. Well, and then return only the result we want, and the work in the coordinator is free, because it's less, because it's just gonna gather the results and show them, but all the work, all the hard work is gonna be done by each shard with each of their rows. So this is very important because XML was not, well, we are supporting more and more XML operators to be pushed down, and then each shard could make most of the work, and then just return the results, and then the coordinator gather the results and show them, and this improves the performance. Okay, so this is why this is very important to push down as much operators as we can, just to use the whole power of the sharding architecture. So these are some operators that we currently support to be pushed down. We have some other operators, but these are the most common use cases. And I'm gonna show, a little example here. So say we are issuing this query from the coordinator. We have the ISO country code, which is the shard key. This is just to show where does the row come from. And then we have the XML cast and XML query operators. So the XML query is going to extract the reference out of the purchase order detail, and then we're going to cast it as a varchar 2 of 30, and this column we're going to call it as reference. And we are also filtering with an XML exists, which is another XML operator. And for this operator, we are getting out the reference, and we're gonna match this reference. So basically what is gonna happen is that XML cast, XML query, and XML exist will be pushed down into our remote query to each shard. Each shard is gonna run the exact same query issued in the catalog, as we're pushing everything. So each shard is gonna run the exact same query, and then return the results, and then just catalog will gather the results and show them to the application. So this is, as I mentioned, the distributed workload that we use, and we take advantage of the whole sharding architecture to distribute the work as well. But there are also some non-pushable scenarios. Basically what we have here is again the ISO country code. But then in this case, we have an XML query where we have first, we have the node that comes from purchase order user. We're gonna delete that from this first instance of the XML. And then we're gonna insert another user. But as you may see, the variable is different. So for this first delete node, we are deleting from the temp XML instance, but we are inserting from the external XML instance. And if we see the passing columns, we say we are passing the purchase order detail from the table P as source, which is this one, and then it's going to be the temp. And we are passing also the purchase order from the external as X, which is this one. And basically what we have here is a join. So there's a purchase order, which is the P, and the external purchase order, which is the external, the ext. And we are joining on some ID, the purchase order ID. But the thing is that we have no way to know in one chart if there's another row that matches this condition. So there's no way for us to push this query into one chart and retrieve an incomplete result, because we need another table that is distributed as well. So as it is a shared nothing architecture, we have no way to tell if there's another row in another chart that will fit into our condition or into our XML query, and we are not showing it. So that's why we cannot push this query to each chart. And what we need to do basically is just to get the whole row, which is purchase order detail for purchase order and external purchase order, and then get back to the catalog. And then once we have it in the catalog, we need to do this XML query. Once we have all the data gathered up, and we have all the results, in that way we can ensure that we're gonna retrieve the correct results in the correct rows. So yeah, another way just to make this pushable is if the XML query we added on the condition the chart key into the predicate. So say we have this on purchase order ID, the same as external purchase order ID, and ISO country code equals the same ISO country code as external. So this way, the ISO country code is going to be region 1 and region 1 for both tables. And that way, we can ensure that the rows retrieved are going to belong to just one chart, and we can push it down and we can gather the results as expected. So there are more pushable scenarios, but this is an example of one. And yeah, we are basically working to support more and more just to enhance performance and use all the sharding architecture. So I have a little demo for you. Let me just bring it up. Yeah, here we go. So basically what I have here is a sharding DB. As you may see, I have here 4 connections. The sharding DB, the catalog, which is the one that sees everything, all the shards. The shard DB, I use USA, Mexico, and Canada for shards. So first, this is the shard 1, this is the shard 2, and this is the shard 3. I'm gonna later show you how to get them. But basically, this is what I mentioned about the direct routing. We can basically have a connection to each shard and issue the whatever DML and DDL we want, because it's an independent DB. And we can see also the sharded and duplicated tables. So let me just get started with this. Just a second. So I'm gonna start with the duplicated table because it's the easiest. I mean, it's easy to get this idea. We just there's no trick here. We just replicate the information across all shards. What is it? Create a duplicated table, transport, what? Yeah, here we go. Sorry, I missed one. So here's the duplicated table. So basically, after doing a DDL in the catalog, it takes a little while. We can set up this refresh rates, but I do this just synchronization, just to see everything right away, or well, when it finishes. So I just created a duplicated table. So if I go here and say describe, sorry about that, describe purchase order. This is the catalog. And then if we go to the USA, oh, disconnect. So we have it as well in the shard 2, which is with shard 1, which is the USA. And then we go to another shard. Purchase order, oops, sorry about that. Forget the P. So here's also the duplicated table in the shard 2. And the shard 3, just a second, I need to reconnect. There we go. There's also there. So we can already see the duplicated table across all shards. And I'm gonna go ahead and insert some data. So this is some data into the duplicated table. I'm saying this is inserted from the catalog, and this is our XML. So if we run this, we just have it. Let me do a commit. And basically, what we're gonna show now, just a second, let me synchronize it. And then there's also a refresh rate for this information. So first it doesn't show, and then I'm gonna run just a procedure to get it refreshed. And then I can go ahead, and here it is, our table. Here is our XML. And here's the duplicated table detail from catalog. Also, I can do it here. I can do it basically in all the shards. Oops. Yeah, again, it is not showing, so I need just to refresh it, and then it should show right there. Again, from catalog. And what's cool about this is that we can also insert into the duplicated tables from each chart. So say we're gonna insert with a 92, another row with 92. This is gonna insert from the USA chart. It's basically the same, but if we do this, we insert it, we do a commit. And then if I go here and say, oh, sorry about that, select star from purchase order dupe, we see both from the USA and from the catalog. And also if I go to another one, see if it's already there. Yeah, already there. So we have in the shard 2, in the Mexico shard, we have both from both rows. The one inserted from the catalog and the one inserted from the USA. And it's the same from the other shards. There's as I mentioned, there's no trick here. It's just basically the same data across all shards, and we can do the DML to the actual table, to the duplicated table as a normal one. We're just inserting, and it's just gonna get replicated across all shards. So this is the first example that I got you for duplicated table. And now I'm gonna go ahead and show you the sharded table. So for this sharded table, this is a purchase order sharded table. We have the purchase order ID, the ISO country code, the name, the detail, which is our XML type document. And we have a constraint, which is formed by the ID and the country code. And we're gonna partition our sharded table by using the ISO country code. So basically when our column ISO country code in our row says USA, we're gonna send it to table space 1. And table space 1 belongs to USA shard. And when it says MEX. We're gonna say to send it to table space 6. And that table space belongs to Mexico shard and so on, Canada as well. Table space 11 belongs to Canada. And yeah, basically this is the DDL for the sharded table. I'm gonna go ahead and run it. The sharded table is already created. And let me just insert some data. Let's get it copied from here. So here, what I'm inserting is the first purchase order. The ISO country code is USA. I mentioned ISO country code, sorry, that this is come from catalog. And we have basically the XML document here. So if I run this, it's gonna be inserted. Oh, sorry, extract. And then I do a quick commit. And then I'm gonna ensure that this is all done and synchronize my shards. So when I go here and say select star from purchase order, I have the row that I just inserted, right? But basically the difference is that when I go to the Mexico shard, there's no row there because we split it into only just one shard. And no, the same happens with Canada. There's no row there. But if we go ahead and insert another row where we say Mexico, and then I go here to the shard to the USA. There's no Mexico there. Sorry, I missed the refresh. Then the refresh. And refresh. So if I go to Mexico shards, it's already there. So yeah, this is the way we configure this to split the information across the sharded DB. And as I mentioned, this is invisible to the user because we're gonna just say, send some query here. And internally, we're gonna gather all the information from each shard and return the rows that we want. So I'm gonna just insert a third one just for my next demonstration. Let me use this a comment and synchronization. And what I'm going to show you now, it's the push down, basically. So let me just show you this. So here I'm in the catalog and I'm doing a query, which is the one we saw in the slides. I'm getting the ISO country code and I'm getting the XML cast, XML query of the reference and cast it, but only when the reference is from the USA. So when we run this, we just basically have the USA row in the ISO country code is USA. But if we remove where the XML exists, it's gonna show all the references. So this is basically what I just mentioned. Each shard is gonna run this query, return the reference, cast it as a barcode2, and return it to the catalog. The catalog just gathers it and shows it. We can actually see this also in the explain plan. Let me just show you explain plan. And basically what we need to see here is that there's a shard iterator, which is the one that's gonna gather all the information. We have a remote query that is the one that is gonna be pushed down to the shards. And what we need to see here is what we are pushing down. So we are pushing a cast, the XML query, and the whole X query within that XML query. And this is basically the remote query that each shard is gonna run, then return to the shard iterator. This shard iterator is gonna gather, and we're gonna return to the actual client, which is the catalog. So yeah, this is to see the push down. And now I'm gonna show you the one that is not pushable. So basically here, this is for later. Let me just comment it. So here, I'm using this to club because it's also not showing. Some of you guys were in the last presentation. The SQL developer is not actually supporting the XML as to show. So this is just a workaround, but yeah, XML code can go and can show across the wire. So basically what I'm doing is getting the same. I'm deleting a node and inserting another, and I'm doing a join. So what we want to see here is the explain plan. Oh, sorry about that. I need to create the purchase order too. Just a second. I forgot to do that. Okay, here it is. So this is a purchase order 2, exactly the same as the first one. Split it up as the same. And I'm gonna go ahead and insert some rows just for this demonstration. Okay. And then I'm gonna do a quick commit. Okay, everything's inserted. Commit. And oh, let me use just the synchronization. Okay. And then again, I'm gonna try the join here. So here it is, just as a proof of concept. What we are doing, we're actually replacing the actions with the sharded table 2. So this is the purchase order 2, but we're actually we have the insert node into the other, and what we want to see here is the explain plan. So here, as you may see, the remote query changes a little bit. We have 2 remote queries and 2 shard iterators. And what we have in each remote query is going to be a column. This column is a binary love that has the XML type information, the XML type document, but encoded into a binary love. So we are going to gather the binary love from each shard and then get it to the catalog. And once in the catalog, we need to do the XML query, because as I explained in the slides, there's no way for us to tell if there are another rows in another shard that fit our query. So that's why we need to gather them all up in the coordinator, and then once there, we need to do the XML query. So as I mentioned, another way to push it down is to include the partition key, which is the ISO country code. And if I do the explain plan for this, what happened here? Oh, I have to, oops, right there. Explain plan. So as you may see here, we now have one remote query. And what we are basically pushing down is everything to club, XML query, copy, whatever. But we can do this because now we are sure that all the rows are going to be in one shard, and we can push this whole query to the shards and get the correct results. So yeah, this is basically an overview of what we can do in the sharded architecture. We have here the connections as independent, and we can use them as independent. But yeah, basically we have a lot more stuff that we can push that we can play around, and that we need to support. So yeah, that's basically all on my side. And I leave it to Rodrigo for the next part of the presentation. Rodrigo, would you like to share your screen, or should I
No,
just?
you can go ahead. Thank you, Alonso.
Okay, yeah, sure.
Actually, Alonso, before you move on, I think there's a question about
Yeah.
how sharding works, which is probably
Oh
good
yeah.
to kind of take now, because they're asking, are sharded databases just partition in the same database, or are they different databases, or are they just materialized views? However, if they are different databases, then why is there no database link?
Oh, they're independent databases. They're not. This is a share nothing. So there are links. If we go to the catalog, this is all routed. Um, Underneath, we're working with DB links. So basically, what we have is independent databases routed to a coordinator. So yeah, we are not partitioning just the information into one database. There are several databases, and we are routing the information that gets inserted or gets issued across each of the shard. So yeah.
So it's the coordinator database that's managing that. Is that right?
Yeah.
Yeah, cool. All right, cool. I think we'll hand over to Rodrigo for now. Okay, thank you.
Okay, sure.
Sure. Okay, so I'm gonna be talking about this new feature that we have in 22C, which is the XML search index. So maybe you were around on the previous presentation with Shen, and I believe she mentioned this the structure XML index, right? So for XML documents, we have a few cases, or rather use cases, right? So you can have an XML document where you actually know its structure very well, right? So you can actually create this structure index over it to improve the performance for your queries, right? So can you go to the next slide, Alonso? But then there's also this use case where, well, maybe your document is not completely structured, right? So maybe some fields will be missing, or the contents will not always have the same data type, right? So in those cases, the structure XML index doesn't really give you a way to properly index your data in your document, right? And so this is precisely the use case with an external search index, right? Because you can actually index, the full document. You can decide just to index some data types on the document, not necessarily, um, strings or numbers or all the data types, right? And on top of that, you also have the benefit that an external search index allows you to do full text search. So if you have any fields that are more free-form, you can also do full text search over them. So next slide, please. So we will go through the syntax a little bit. And so for those familiar with the JSON search index, the syntax will be very similar, where you have this create search index statement. And you give it just the index name and the table name as well as the column, which will be it has to be a transportable binary XML column. And you give it this for XML clause, right? So this marks or search index has been indexing for XML documents. And you also have this parameters clause which you need to use to determine what type of indexing you have, right? So if you omit this specifically is like this search on clause. And so if you omit this search on clause, what will happen is that you will get a purely full text search enable index, right? So this is similar to another feature that we have, which is the xQuery full text index. So essentially, this will be another flavor of an xQuery full text index, right? So by default, if you have the full text search enabled, you will be able to use the contains text, FTN, FTOR predicates from an XML query syntax. But you can also have additional indexing, right? So you're not restricted to searching on full text. You can also tell it that you want to index on value, and you are going to be giving it a few data types, right? Which are the data types that you want to index from the document. So the supported data types are number, binary double, timestamp, and bar chart. So that means that you're basically able to index numbers, date times, and keywords on your document, right? So you can and you can do that for specifically just to index those as values in your document, or you can also use this search on text value to have both of them, right? So you can have both a full text search enable index while also indexing a few of the values as standalone, right? So next slide, please. So now we will go through each of the syntax and a sample query that you can use. So as we said before, the default is search on text, but you can also explicitly specify it, right? So you can do this create search index for XML with search on text, right? Or as we said, it's the default. And this will allow you to do this XML access query, but it contains text X query predicate, right? So in this case, what we will be doing is that we'll be looking at the line item for our document and searching for the text Julius on the description field, right? And this is a very simple query, but you can also use and or to add additional predicates, right? Not just the full text search index predicate. Next slide, please. And so opposite to that, we have search and value. And as you see here, between the parentheses, you actually need to specify the data types that you want to index, right? So in this case, we want to index binary doubles, or rather numbers as binary double type, and keywords, right? So we give it the bar chart to data type. And this allows queries like the following XML assist, which is saying, okay, look at the unique price and return me the document if it has it's greater than 20.5, right? In price. Or you can look at the description and do like this range search over the keyword there, right? So in this case, it's looking for items whose description is greater than light, right? So usually the X-query syntax is fairly obvious which data type you should, but for example, in the case of numbers or data types, you might want to use this access cast function, right? So in this case, we're casting to double, and volume mode allows you to do range search, right? So if the only caveat here is that because you're only indexing values as a standalone data, your index will not be able to do full text search, right? So this is kind of an opposite case to what we had before. And we also said that you can mix them, right? So next slide, please. Alonso. Oh, sorry. So you can mix them both, right? So you can also do text value modes. And in this case, it's not indexing keywords, but it's indexing date times. And so this allows you to do this query over datetime, as well as doing this other query that we had before, which is the full text search. And both of these queries are very simple, but you can use additional predicates, right? So you're not limited to a single predicate. So this order date predicate here on the top could also be part of the second query, right? So you can sort of like customize your index to fit whatever type of index in your document requires, right? Especially if you don't have like a structure, or maybe you want to support out of queries over your data, because you don't know which queries the user might be issuing to your document, right? So this is a little bit of the syntax, and now so Madhu will talk a little bit about in which cases we pick up the search index, right, when compared with our other options. Sumeto, if you could take it away.
Thank you, Rodrigo. So I'm going to talk about a few cases that you need to keep in mind when creating an XML search index. Next slide, please. So we have two different kinds of indexes for XML type data. The structured XML index, which we also discussed extensively in the previous session, when your XML type data can be represented in a structured format. And the XML search index, which we introduced in this section, when your XML type data can be represented in an unstructured format. However, when both the indexes are present for the same XML type data, then for range search queries, our structured XML index takes precedence over the XML search index. If you want to override this and enforce the use of XML search index, then you can use this pragma aura use XML text index. And this will make sure that the XML search index is picked. And the second for full text search, as usual, XML search index is picked as the structured index does not have that capability. And lastly, if you use the no index hint, then you can avoid the usage of indexes at all if for some reason your application does not want to use both the indexes. A couple of examples here. The first one demonstrates the use of the XML text index pragma, wherein we specify aura use XML text index in front of the XPath expression. And this query will make sure that the index is picked where you're looking for all CDs that is greater than the date mentioned in the query. And the second example shows the use of no index hint, where you specify no index followed by the table name and index name. And this will make sure that the index is not picked for the following query. The next slide. Also, you need to keep in mind the following restrictions when using an XML search index. The first one is that the XPath expression that you mentioned in your query needs to be in the forward direction, or it can have like descendant axis, which basically means the children of the current node, but it cannot be in the backward direction, as then have a parent axis or wildcard prefix or wildcard attribute. Also, you can pass only one XML type instance in the passing clause of the XML query. And also, when you're using range search predicates, the comparison value must be a compile time constant, which means that it should not depend on other column values on a row by row basis. And also for the not equal to operator, the index is not considered. So you need to keep in mind the following restrictions when deciding when you're designing your application. The next slide. So in the previous section, we introduced Transportable Binary XML, or TBX, which is the recommended storage type for XML, all XML type data from 23C. And XML search index is built exclusively for Transportable Binary XML. So the usage of TBX and XML search index is the recommended model for XML type data from 23C. The usage of XML search index allows greater flexibility in data partitioning and also flexibility for unstructured data. So if you have legacy queries stored as non-TBX, and if they use the SQL contains function, you can migrate to TBX and replace the contains function with XML exists. Similarly, if you have legacy queries which use the old context index, then you can again move to XML search index. So the XML search index is built on the text context framework, and the type of the index is context v2. The old index was context, while the new one, which is XML search index, is context v2. You can use the following queries to identify your existing indexes from the user indexes table. The old one was context, and the new one is context v2. Similarly, you can query user XML tab calls. The old storage type was binary, and the new one is transportable binary. So yeah, it's a pretty cool feature, and it is recommended that you move to the storage model. Now I'll show you a quick demo to demonstrate the usage of XML search index. Can you see my screen?
Yep, we can see it. Thanks.
So this instance is running on Oracle Cloud, and I've opened the SQL developer shell. So what we're going to do in this is that we're going to create a TBX type table, insert a couple of records, and then we'll be creating different kinds of XML search indexes and run some queries to see if the index is getting picked. So I'll first make sure that the table does not exist. And then I create a table called purchase order, which has an ID number field and an XML type field, which is stored as transportable binary XML. So you can specify store as transportable binary XML. And the table is created. In order to verify the storage type, you can query user XML tab calls. And it should be mentioned, the storage type should be mentioned as transportable binary XML. Now I'm going to insert 3 records into this table. These are non-schema based XML documents. They don't conform to any schema template. They're free-form XML type data. These are sample purchase orders, where each purchase order has variant fields like the order date, shipping instructions, line item, along with the details of the line items. So I insert the first record, the second one, and the third one, and commit it. Okay, so now we have 3 records in our purchase order table. And now I'll be creating different kinds of XML search indexes for the underlying purchase order table. I drop all indexes, so there is no pre-existing index. The first index that I create is a text index, where we specify search on text, and sync on commit implies that the index will get synced every time I commit a record in on the base table. So create search index, the index name on the table name followed by the column name. For XML is optional, followed by the parameters search on text. So this creates a text index for the base table, which is purchase order. If you want to verify the index details, then you can query all indexes or user indexes. when you query them, you can see that a function-based domain index is created, and the index type should be context v2, which is the type for XML search index. And I run some text queries to check if the index is getting picked. The first one checks if the description field contains text Julius. So I'm using an XML exists here, and I want to select all the IDs that have description with the text Julius. There is one record. So if you look at the original table, there is one record with Julius Caesar in the description. And if I explain the plan, I can see that the index is getting picked. You can see the usage of domain index, PIDX. PIDX is the text index that we created. And you can run different kinds of text queries. For example, I can use the FT and operator if I want to find all addresses which contain both Oracle and Austin, then I use the FT and operator. This one returns all the purchase order IDs, which contain Oracle and Austin in the address field. So this returns the second record. You can see it contains Oracle and Austin. And if you look at the plan, you can see the usage of the index. The third one, we use the FT not operator, which negates the Austin usage. So basically shipping addresses which contain Oracle and do not contain Austin. This one returns the first and third record. And if you explain the plan, you can see the usage of the index. The fourth one returns addresses, records which have Oracle or Austin in the address. So we use the FT or operator. And this one returns all the three records, and you can again see the usage of the index. So basically this one shows the usage of search index using text mode. The second one, we look at value mode. Value mode is used for range search queries, range search like greater than or less than, for the data types that you can specify explicitly. So in our XML document, this one looks for all the elements or attributes with values having binary double or varchar or timestamp. So you can specify the data types that you're interested explicitly. The part before that is similar to the text syntax, where you create the search index on table name followed by column name for XML, search on value mode for binary double, varchar2, timestamp, and you sync on commit. So I'll drop the existing text index and create a new value mode index. So the index is created. You can again query user indexes and verify the index details if you want to. This one, let's run a few example queries on this. So I have a couple of range search queries. The first one outputs all purchase orders where unit price is greater than 500. I typecast this by XS double. This is optional. You can typecast if you want to avoid confusion in certain scenarios. This one basically outputs the second and third record, and we see that the value mode index is getting picked. If I want to query all orders after February 5th, then I can specify the order date followed by date time and the date. This outputs the third record. So if you look at the third record, you can see that the order date is the 8th of Feb. So this is the only record that was there after the 5th of February. And we can explain the plan to see the usage of the index. And the third one looks for all descriptions greater than lava. So this is lexicographically ordered, and I have two records here. If you explain the plan, you can see the usage of the index. So basically this one is for value mode. The first one was for text mode. The second we just saw was for value mode. The third one we looked at is text value mode, which basically blends the text mode and value mode, and both are enabled. So it can be used for full text search, as in case 1, as well as range search, as in case 2. So I drop my previous index and I create the third type of index, search on text value. For this one too, I specify the data types explicitly for the values that need to be enabled for range search. And the index is created. So you'll see here that the same index can be used for value queries. For example, all orders with unit price greater than 500. This one will pick up the index. Similarly, all orders after 5th of February, this picks up the index. And the third one is a full text query, where we look for all descriptions that contains the keyword Julius. And this one picks up the index as well. So you can see, you can use the text value mode if you want to enable both. So we saw all the 3 different kinds of indexes here. Lastly, if you don't want to use the index, then you can use the no index hint followed by the table name and index name. And this will make sure that the index is not getting picked. If for some reason you don't want to use the index, you can see that it goes through full table access. And a final item that we spoke was that if both a structured XML index and an XML search index are present for the same table, then the structured XML index takes precedence. So here's a short example of a structured XML index, which is created on the same record for the same table and column. So for purchase order, I create a structured XML index. You use a structured XML index when you can organize your XML data in a relational format, as you can see here. And you specify the format of the index like this. If I query user XML indexes, user indexes, I have a context index. So I have the same range search query where I'm looking for all records with unit price greater than 500. And this returns the output. But if you look at the plan, you can see the usage of structured XML index. Previously, the XML search index was used, but over here, the structured, if you look at LI tab, it is the table that we specified when creating the structured index, and that's getting used now. However, if we want the XML search index to get used, then we specify this pragma use XML text index in front of the expression. And if you look at the plan now, you can see that the domain XML index is getting used. So that was pretty much the summary of the capabilities of our new XML search index. Alon, so if you can go back to the slide.
Sure. So basically a little summary of the whole presentation is just to improve your performance and as per sharding and also index. We gotta keep the information where it belongs in its own region. We can store, use, and manage relational data in XML documents in several databases across different geographical regions, and they all act just like one. This is a unified management, security, and consistency model. And also there's a flexible relational and XML access of your data, leveraging Oracle Databases core enterprise features for availability, security, scalability, and performance. So here are some reference for you in case you have some more doubts or you want to jump into this deeper. So yeah, that's all on our side. If you have some questions, you can go ahead.
So that's great, folks. Thanks. Yeah, as Alonso says, if you've got any questions, then please put them in now. Obviously, if you think of something later, we're always here to help, and you can pass them over to me, and I can route them to Alonso, Mado, or Rodrigo as necessary. But I think there was some things which came in the Q&A. I think they have been answered. Yeah, just kind of cover off. They were asking if create search indexes is 23C feature, and it is correct. That's right.
Kind of. So the new feature is for XML, right? So
okay,
the create search index syntax has been available since 12C for JSON, and then it was made available for regular text indexes in 21C.
Okay, that's great.
So
Thanks.
the one specific for XML usage is 23C.
Got it. That's great. Thanks, Rodrigo. Thanks for clearing it up. So most people should be able to use search indexes to some degree at the moment, right? But it's the for XML clauses that they need 23C for. And I think there's, I think Chin's typing an answer, but let's see if anyone else can help for this. So if the XML is saved as binary transportable, why the insert statement where just text column and not a binary file object? So
Alonso, you want to take that, or should I? Okay, so maybe he could pitch in a little bit.
Yeah, I was mute.
Oh no, sorry.
Yeah, go ahead, Rodrigo. Yeah.
Oh, so that the binary format represents the data as it's stored inside the database, but it's not. So it's not user friendly for the user to actually have to have a binary document that they insert, right? So the client can send the data as text to the database, and the database takes charge of when it stores it in our arbitrary binary format.
Cool. So you don't have to worry about doing the translation yourself. The database is taking care of it for you. That's basically it. Is that right?
Mm-hmm.
Exactly.
Cool. Alrighty then. I haven't seen any other questions come in. Any final comments or things you want to say before we say goodbye, folks? Or
thank you very much. That's everything.
No, cool. All right, thank you. As I say, thank you, Alonso, Mado, and Rodrigo for joining me. As I say, you'll know more about XML than I think I ever will, right? So good to have your expertise to help explain how these things work. And so all that's left for me to say is, those of you joining us, I really hope you enjoyed this. More importantly, I hope you learned something, and we'll see you next time in March's SQL Office Hours. Goodbye.